Hi there, and welcome to 272analytics.com's tutorial on how to carry out a one-sample t-test in R. In order to do so, let's start by loading the pre-existing datasets in R using this command and pressing enter. And scrolling up and down here, we can see in alphabetical order the datasets that exist here that we can work with easily. I'm going to pick orange today. And in order to do so, let me just type in this command, get orange loaded, and then I'm going to type orange again so that we can see the actual values in the data set right here. So it seems that we have data on 35 trees with age and circumference being the main variables of interest. And let's go ahead and load some of these variables here as vectors using this code that I'm going to show you here. I'm just going to create a variable age, a variable circ here as vectors, and now we see that these values are loaded in here. And now we can start to manipulate them. So the first thing I want to do is generate a mean for age, and it looks like 922.1429. I'm assuming that's months. So let's do this. Let's do a t-test, a one sample t-test, and then I'm going to walk you through what's in the code, what it means, why I did it, and so forth. So the first thing is to pick what's called mu, or our hypothesized mean. And I'm just going to highlight that for you there. And then I'm going to highlight the entire code snippet so you can see what I did. And note that age is the name of the variable here that we gave when we loaded the value in. So what is a one sample t-test? A one sample t-test is when you try to figure out if the mean of a single sample is significantly different from, lesser than, or greater than some hypothesized mean. So let's set that up in a practical format here. Let's assume that we are testing whether the mean age of trees in this data set is significantly different from 700. So what we pulled up was a mean, but we don't know anything about the deviation or the distribution, so we can't really be sure until we run the test of whether this observed mean is different from, or lesser than, or greater than some hypothesized mean. Let's go ahead and run that t-test and then look at the results. So your key result, the first thing you should look at in any t-test, one sample or otherwise, is the p-value. And so here we see that this finding is statistically significant. And what we can tell here is, because this is a two-tailed test, it's different from, not lesser than, not greater than, it's a two-tailed test. So what we know is that this sample mean of 922.1429 is significantly different from this hypothesized mean of 700. That doesn't tell us whether it's lesser or greater or anything like that. So I'm going to follow up with another command here in R. And let me scroll down so you can see it. We're using this alternative less, and everything else is the same. And by the way, I should quickly point out that you can set the confidence interval to anything you want. I've just put in 0.95 because that's standard in statistics. So now what do? We've created this alternative command, put it in there. And now we're actually seeing a different hypothesis that's being tested. Is the mean less than 700? Okay. And you know that it's not, because the p-value is up over 0.05. But what you can do here is you can actually figure out the p-value of the true mean being greater than 700 by just doing this. There. So whatever this value ends up being, and let me just do it on the calculator here just to highlight it. Okay, 0.0057. That's your p-value of the observed mean being greater than 700. And you know how the other way you can get that is just by dividing this by 2, which is the same thing. So basically, with this t-test, we figured out that the calculated sample mean of 922.1429 is both significantly different from 700 and significantly greater than 700. Now, I'm just going to emphasize those because, especially when you're starting out with t-tests, the idea of different p-values for different tails might not make sense. It's something that you could read more about in your statistics books, how that works. I just want to make sure that when you do this in an applied format in R, you know that there is an important difference between the p-value that you get for the sort of unaltered test here, which I'm highlighting, which is a two-tailed test, versus the p-values that you're going to get when you type in alternative here. And using that, you can work backwards and figure out the p-value for the mean being greater than mu as well. So one more thing that probably would be nice to do here is just create a box plot and get a look at the data. Okay, so there's your box plot. There's your mean, and you have your interval here with the whiskers, the upper and lower ones, and so you get some idea of the distribution. And you could go ahead and you can do a histogram and other manipulation. I prefer to start with a box plot when I'm doing a one sample t-test, just so that I can see if they're outliers, and it's just a habit that I have. But you could, of course, if you wanted, start with a histogram as well. I hope this tutorial was helpful to you, and I would like to invite you to visit 272analytics.com for access to all our free statistics tutorials in Stata, SPSS, R, eViews, and Minitab. Here at 272analytics.com, we provide data consulting primarily to graduate students. Therefore, we work very closely with you in order to perfect your Chapter 3 and Chapter 4. That means helping you design surveys, getting your data input, assisting you with fashioning appropriate research questions and hypotheses, getting your data, extracting them, transforming them, cleaning them, putting them through analysis, interpreting them, explaining them to you, so that at the end of the day, you know exactly what story your data tell, why they matter, what they mean, in a manner that lets you write a perfect Chapter 4 following a perfect Chapter 3, and lets you defend your dissertation or thesis with complete confidence. We provide ethical consulting. It's not a writing service, so you will be responsible for taking our blueprint, our assistance, our consulting, and transforming them into an appropriate academic project for yourself. I'd also like to remind you that we provide the same services to undergraduate students who are working with quantitatively oriented assignments. Thank you so much for listening, and have a great day.